Automation is very important to us at Ocado, from automating our delivery warehouses with robots right through to building and testing our mobile applications. Today, I'll be discussing the build pipeline and testing approaches we use for both our Android and iOS shopping apps. There'll be a particular focus on the ways we are reducing the number of manual steps and trying to automate as much as possible. Just to kick things off and to help understand the context of our user base, I have a few key Ocado statistics. We're the world's largest dedicated online grocery retailer, serving orders to 500,000 active customers. 200,000 orders go through our two large distribution centres every week, which consist of over 50 miles of conveyor belts. And our systems compute 3 million routing calculations a second. The mobile team develops the shopping apps for Ocado Retail and for Morrisons, which are available for iOS via the App Store, and Android via Google Play and the Amazon App Store. The apps have evolved over a number of years with an ever-increasing feature set and set of screens. Also, even though the app will allow you to shop offline with a fully offline catalogue, it is primarily an online service, and so the app is very dependent on a set of back-end services. This can make automating and testing a difficult problem to solve, especially when it comes to reliable testing data. However, manually testing a growing feature set isn't the most scalable solution, and so it becomes increasingly important that we automate as much as possible. Alongside improving the apps, we have incorporated new tools and quality assurance techniques into our development environment. This is to ensure greater stability, reliability, performance and quality of our apps. It is also to provide a greater level of automation and reduce manual effort for our developers, so they can focus on implementing features. The first measure we introduced was manual testing before each release of the app. This consists of running through a spreadsheet full of tests on a set of different devices and OS versions. The issues that are caught primarily by release testing are areas which were unexpectedly affected by a change, or areas in which multiple changes interact with each other. This process is still currently operated, however we do aim to reduce it through automated UI tests, which I'll talk about in a bit. Continuous integration is a very important tool to ensure the changes included by all developers interact with each other correctly. Each source code repository contains a main development or master branch, into which all changes are merged once they're completed. This allows a set of CI jobs to run whenever a change has been merged. They create a build, run a suite of tests, and perform a variety of code quality checks. Although more related to data and behavior analysis, analytics tools are an important aspect of automation. By incorporating analytics tools, we can monitor many aspects of user behavior within the apps. We can monitor app crashes, where they are happening, how often they are happening, and the steps taken leading up to the crash. We can also monitor actions a user has taken and information about their session. By collecting this data automatically, we can reduce how many manual user experiments we need to run, and they can also allow us to tune our apps to better suit our customers without much manual effort. Unit tests are one of the first lines of defense for maintaining your code's functionality. Each test checks the functionality of a particular component in isolation from the others, for example, a particular method or function. The tests for a component should document its intended behavior. The unit test suite should aim to cover as much of the project as possible, ideally 100% of the app's code. However, this can be an unreachable goal due to external dependencies or the environment itself, so instead it's best to just aim for as high coverage as you can. Your unit test suite will be ran very regularly, and so it's crucial it runs as fast as possible, preferably in a few minutes or less. The time taken will depend on the type of project, programming language, and the environment, however. As part of our continuous integration build, we perform a set of code quality checks automatically. These check the code conforms with the documented code style, they check for coding errors or potential bugs, and they can also analyze the complexity of the code and its dependencies. Many of these things are an automated version of what we would have checked manually during testing or a code review. As the team grew, we added a dedicated quality assurance tester into the team. For each change, they manually test that the functionality is working correctly. This includes edge cases and situations the developer may not have thought of. Once these tests are complete, the change can be merged into the main development branch. The main benefit of having this QA step is that the tests are done by a dedicated and experienced tester. An area in which we are trying to improve is user interface testing. This involves executing a test suite on the app running on a real or virtual device. The tests will interact with the screen like a real user, performing clicks, gestures, and inputting data. They are very hard to get right and also very hard to keep reliable. You can often have a test suite which regularly fails due to environment or device issues rather than bugs in the app itself. It's therefore important to run the tests against a very stable environment. You'll need a reliable data set, and if you're performing network calls, you'll need to know that they won't fail unexpectedly. If done right, you'll be able to write automated UI tests which replace your manual tests. They could be run as part of your CI, they could be run as part of release testing, or you could just run them on a schedule such as once a day. For running your UI tests, there are many device cloud services available. These services will allow you to run your tests on a large variety of real or virtual devices and OS versions, meaning that you don't have to maintain the set of devices yourself. We have only recently started investing in UI testing, and so the test suite we have is still relatively small. However, we have managed to keep it fully reliable so far. To test new major features, or to experiment with variants of a particular feature, we use A/B testing. A feature flag is used within the code to determine which option to use, and then on the server, you can assign customers to 50% to group A and 50% to group B. We can then monitor a set of metrics which are selected for this experiment. The outcome will allow you to choose which of the options to roll out for all your customers after the experiment is complete. When it comes to replacing manual processes with automated ones, there can be many difficulties we have had to overcome. The most difficult to overcome concerns using UI tests in place of manual testing. Writing a full suite of UI tests which covers all the different user behaviors can be a very time-consuming task. Depending on how your company operates, it can also be hard to get these tasks prioritized due to it providing less obvious business benefit than, say, adding new features to the app does. On top of this, writing the UI tests so that they are stable and only fail when there's an actual bug that needs fixing is also very hard. Most people you speak to who maintain a UI test suite will probably mention how they fail a lot. This is down to the inherent complexity of interacting with the app like a user or issues with external services. For example, if your tests run an app that talks to a back-end server, or even a test back-end server, then if the server goes down or returns incorrect data, the test will likely fail. This can be resolved by maintaining a testing server which serves a predictable data set, or through mocking the entire network layer in your tests. Over the years, we've also suffered many issues with maintaining our CI servers. My suggestion in this area is to just use a managed cloud continuous integration solution, if this is an option for you. The way the CI is managed for you means you don't need to spend time upgrading it, keeping it up to date, and managing it, and you can simply just write build scripts and config files. By resolving any issues you face, automation comes with many rewards. It frees up your developers' time to focus on improving the apps, rather than spending time testing or checking it. Through automation, you can speed up your time to release changes. This allows you to get your changes onto your users' devices much faster than before. Manual testing can also be less reliable than automated testing. A tester could miss some test cases, or you might not test on a particular device or OS version. Automation here will increase the stability and reliability of your apps, as it has been done for ours. In general, it will result in developers being happier, who have more time to develop and feel more empowered. In the mobile team at Ocado, there's still much more we can automate. We've only recently started investing properly in our UI test suite, so much more work needs to be done in that area. I would also like to fully automate our release process, including introducing automatic releases and a continuous delivery process for the apps. Another interesting area that is starting to grow is automatically comparing screenshots of the app so that you can monitor unexpected changes in the UI. In the mobile team at Ocado, we develop shopping apps for both Android and iOS. Therefore, it's important to offer a consistent experience to your customers when using the apps on the different platforms. However, it's also important that you account for the platform standards so that users find your app familiar, as they do for the other apps on their device. Currently, to try and solve this problem, we are developing a design language to help our UX designers create designs that are consistent across both platforms. I'm not suggesting that every UI component needs to look and behave in an identical way on both. Android follows material design, and iOS follows the iOS design guidelines. There are often differences between the platforms. For example, on Android, to show layers of your interface, you generally use elevation, which consists of shadows behind your views, whereas in iOS you generally use blurring or color. What we want is to be consistent in the experience the user has. This involves a familiar app hierarchy of pages across the two platforms. Features should be in the place the user expects and should work in the same way. Also, very importantly, each app should be consistent with itself, such as UI components being the same across the app. For example, if you have a card on the home page, it should be similar and work in the same way as a card on, say, a slot page. It shouldn't look and feel different. Generally, when our UI component design doesn't conflict with the platform guidelines, they will probably likely look the same or similar on the different platforms. As an example, you can see on the home screen above. The consistency of the UX is an area we're working on actively at the moment, and it's something we've always struggled with. This can come through designers who work on the apps changing and not knowing about why designs were made in a particular way. It can also come through the fact that it's hard to learn how to create a design that fits web, Android and iOS. There are many areas of the app which need to be improved, and our design language hasn't been fully defined yet. However, it's something we're working on and it's very important to us. We obviously want to ensure that our app provides a smooth experience to our customers. For us, the most important metrics would be memory usage, to avoid out-of-memory errors, page load times, and lag within scrollable views. Unfortunately, we don't have any automated performance testing. It's also something we don't specifically test for manually either. It's more that we notice it whilst doing our standard release testing. We're currently looking into performance monitoring tools such as New Relic. This would enable performance to be monitored and the suboptimal areas of the app to be detected automatically. We would then also like to look into having some automated tests which check for app performance, such as allowing us to catch issues sooner. However, performance can sometimes be quite hard to represent accurately, hence why we haven't done much on it already.